With this Hughes Views, I'm going to talk about volume and density, more so density than volume. So when we talk about the volume of something, we're going to talk about the amount of space that that object occupies. Sometimes when we think of volume, you might think of a liquid amount of volume, but a volume can also think of like a solid amount of volume. So volume can be, this is a little piece of Wood's metal, which is a mixture of 3 different types of elements from the periodic table. But the volume that this metal takes up, we could measure the length, the width, and the height of this tiny little bar, and you could get the volume. Okay. So volume is in terms of the liquid amount, maybe we're thinking like a cup or a milliliter or 1 whole liter or a gallon, right? So those are different ways to describe what volumes are. So remember, if we take a length times a width times a height, that would give us something to cubed. And when we're taking lengths, we can either be in decimeters or centimeters typically. And 1 decimeter cubed is the same thing as saying 1 liter. So those are good ways to kind of to levy back and forth between length, length times width times height. So thinking length measurements and thinking more about liquid measurements. Mostly you'll see in this course the centimeters cubed. Okay, so 1 centimeter cubed is the same thing as 1 milliliter. And you'll actually use a lot of this in your lab when you're using graduated cylinders to measure out 1 to 10 milliliters of a solution. So that's what 1 cubic centimeter is 1 milliliter. Side note, if you ever watch any type of hospital TV shows or movies and they say, I need 1 cc of blah or push 2 cc's of blah, cc is standing for cubic centimeter, right? Cubic centimeter. So if they say they need 1 cc of something, they just need 1 milliliter. Or push 10 cc's of epinephrine, they need 10 milliliters of epinephrine, which actually sounds like it would kill somebody. That's a lot of epinephrine. I guess it would depend on the concentration, but I digress. Okay, so here's maybe another visual representation. So we have like a length times width times height, so a solid object. And if we look at, if we're taking that measurement in meters cubed, so here's our meter cubed, right? So there's 10 decimeters in 1 meter, so there should be 10 of these boxes for every 1 meter. So here's our 1 decimeter cubed, right? Because it's 1 decimeter by 1 decimeter by 1 decimeter, so length, width, height. And so that's is the same amount of volume as 1 whole liter. And then you could break down the decimeter into centimeters. So there should be 10 centimeters in 1 decimeter. So if you look at that tiny cube, you get your 1 cc or 1 cubic centimeter is equal to 1 milliliter. Okay. We are moving on to the next. So that just kind of put that into perspective. All right, so here we are, density. This is a very, very tricky subject that students find confusing a lot of the time. So the density of a substance is the ratio of the mass of that substance to the volume that substance occupies. Okay, so density is equal to mass, which is usually in grams, over volume. And volume here you'll see as either milliliters, usually if we're talking about a liquid substance like water, you'll see that it's grams per milliliter, but sometimes in a lot of those old textbooks, you'll see this centimeters cubed. So it'd still be grams over centimeters cubed, which a centimeter cubed is a milliliter. I cannot hit that home enough. All right, so that's the density. All right, so why does it matter and what do you use it for in chemistry course? So I've got 2 little bricks. One's a rod. This is an aluminum rod, and this is that Wood's metal, which is a mixture of 3 different types of metal at different percentages. But you could probably sit here and argue with me that they're about the same volume, right? So, I mean, they have a similar length. This one's got a little bit extra kind of mess on it, so maybe that's where this extra little length on my aluminum rod can take up, but so super similar volumes. I just went and weighed these, and the aluminum rod weighs 6 grams, and this Wood's metal rod, what do you think? Weighs roughly 6 grams, weighs 3 grams, weighs 10 grams. I tell you, it feels heavier, and I would say that would mean that it feels a little more dense, right? It feels a little dense. This actually weighs 30 grams, so it's 5 times heavier than this aluminum rod. So even though the volume looks like it's roughly the same, the mass was different. And that is where the density comes into play in a bunch of chemistry problems. So you might, in a question, be told that you're starting off with 10 milliliters of ethanol, and you need to figure out how many grams that weighs. And so that's where density will help you out. So if you have your 10 milliliters, which is milliliters is a volume, and you multiply it by the density of ethanol, which is in grams per milliliter, you should be able to figure out how many grams 10 milliliters of ethanol weighs. The easiest number to remember is water. Water has a density of 1. It's roughly 1. I mean, in class, you'll see that you'll find given the temperature of water, what the exact density is, but it's like 0.999899979. It's really close to 1. So as a general rule of thumb, we say water has a density of 1. That means it's 1 gram for every 1 milliliter. So if I had 10 milliliters of water, I could say that weighs 10 grams. And I know that because of the density. Ethanol, on the other hand, has a density of, I'm pretty sure, it's 0.92. So it's a little less than water, right? It's less than 1. And you could say that 10 milliliters of ethanol then weighs 9.72 grams. So this is, again, where density is going to come into play. So if you have more questions on density, please feel free to contact me. But there'll be practice problems in your homework to work on that will help you, test your knowledge on your understanding of density.